This is the thing that we love this here.
Lesson 19, the derivative. So 3 big topics in calculus: limits, derivatives, integrals. We've already started introducing limits. We've done some with limits. Now we're going to start introducing derivatives. Doesn't mean we're done with limits by any means. We'll keep doing lots with limits. But with the Saxon book, we kind of, introduce bits and pieces here. So derivatives. Now, I am introducing the definition of the derivative today and how we use the definition of the derivative, which is, to be honest, a long, drawn-out process. Give it another week or two, and we will learn the shortcut for derivatives. And you will love the basic idea of taking derivatives with shortcuts. Okay? However, with that being said, the AP test, there is an importance to understanding the definition of derivative, to being able to recognize what it looks like. Okay? And we'll talk about that more as the year goes on. Derivative. Okay, definition here, guys. The derivative of a function at a point is the slope of the tangent line to the function at that given point. Okay, derivative, slope of the tangent line. When you are asked within a problem in calculus something involving slope, your brain needs to immediately think derivative. Okay, so slope of the tangent line of the curve. So, in other words, you guys have been working with this a little bit. Here's my parabola, right?
Yep.
So then, I'm not going to be able to do this justice. There's my tangent line. So what we're doing, it's the slope of the curve at the given point. So if we're trying to find the slope of this parabola at this point, you're looking for the slope of this tangent line. If we want the slope over here at this point, then we're finding the slope of this tangent line. Okay? So a straight line has one constant slope, yes? A curve has many different slopes, depending on what point you're at. So, everyone's got that, right? Derivative of a function at a point is the slope of the tangent line to the function at that given point. Now, definition of the derivative. There's technically about 3 forms of the definition of derivative. The one I'm introducing today is this right here. First of all, you see that little, what do you want to call it, apostrophe? Is that what that is to you guys? In math, that notates a derivative. We read it f prime, and so f prime of x, or the derivative of f of x, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. The same thing could be done using h's. You've seen some of both in homework, I think, already. Delta x's and h's in this format. Other notation for derivative. So f prime of x is most common. So f prime, you will also see y prime. Okay? D dx, so that is the derivative with respect to x. Capital D with a subscript x. Honestly, I don't usually see that, but it's a good one to know. Dy dx is very common, the derivative of y with respect to x. And this is the same thing, derivative of y with respect to x, this d subscript x, y. Okay? Example 1. Let y equals x squared, find dy dx. Now, if you'd prefer, instead of y, you can think f of x equals x squared. And then what that means they're asking you to do is to find f prime of x. Okay? And you can also write y prime too. So I will use that at some points too in saying y prime. But we're using the definition of derivative today. So, if f of x equals x squared, f prime of x. You ready? And when they ask you to use definition of derivative, you have to show this work. So, dy dx, derivative. Okay, what's my definition up here? The limit as delta x approaches 0. So, limit as delta x approaches 0 of f of x plus delta x. What is my function? My function is x squared. So every place I see an x, I'm replacing it with what? X plus delta x. So here it says to square whatever x is. What is x? X plus delta x. Quantity squared. So right there, f of x plus delta x plus delta x, quantity squared. Minus, what's it say to do now? Regular f of x. What is regular f of x? X squared. All over delta x. Now, with the definition of derivative, you have to do some algebra here. Because if I just put in 0 for delta x right now, I'm going to get 0 over 0. If we do some algebra, my delta x's will cancel out to the point where I won't get 0 over 0. So, equals the limit as delta x approaches 0. What do I have to do on top? FOIL. X times x is x squared. X times delta x. X times delta x is going to be x delta x plus another x delta x if you do outsides and insides. And that's going to be 2x delta x plus last delta x times delta x is delta x squared. And then don't forget, what did we already have here? Minus x squared. So we had to FOIL. We did our FOILing, and then it was still minus x squared all over delta x. Okay, do you see what can happen next? First of all, the x squareds cancel. X squared minus x squared is gone. What do you notice about what remains on top? Yeah, both terms on top have a factor of delta x. So I'm going to factor out delta x on top, which if I factor out delta x, that means I'm left with 2x on this term, plus, if you have delta x squared, you factor out delta x, we're left with delta x all over delta x. Now what's so nice? Delta x's cancel out. And so now my problem becomes the limit as delta x approaches 0 of 2x plus delta x. And now that that fraction's gone, can you substitute the number value in now? So if I substitute the number value in, I now have, every place I see a delta x, I replace it with 0. So 2x stays 2x plus delta x, which is 0. What is 2x plus 0? 2x. So all of that worked to say the derivative of x squared is 2x. And that was because we put in 0 for x right there, or delta x there, if that helps. Okay. Questions on that first use of the definition of derivative? You will eventually have that memorized. You'll have to have it memorized just to use it. Okay? Ready for example 2? Given f of x equals x squared. Find the slope of the line tangent to the graph at x equals 4. Any thoughts? Okay. Right here, guys. Slope of the line tangent. What is that in other words? Derivative. Remember how I said when you see those words in calculus, you need to have like a red light flashing in your brain that's saying derivative, derivative, derivative. Here it is. Slope of the line tangent to the graph at x equals 4. So I agree with what Nathan is what that's supposed to be. Woof. I'm tongue-tied on this Monday. In that we're finding the derivative at x equals 4. Now, what is this given function? F of x equals x squared. Is that familiar? Didn't we just do this? Okay. Use your resources. If f of x was x squared, what is f prime of x according to our previous problem? 2x. Use your resources, guys. It's not cheating when you just did the work, right? Unless you really want to practice that definition of derivative again, but we'll do it with some other problems. So what's this mean? If it says at x equals 4, then that means I need to find f prime of 4, which means I'm doing what? Hard math here, I know. 2 times 4, which is 8. Well, keep in mind, though, that problem, technically, that's like a part B to the last problem. It was only easy because we'd already done that definition of derivative. Okay. Sample 3. Let y equal 4x. Find derivative of y with respect to x. Any thoughts? What do you mean plug and chug?
Put it in the definition.
Put it in the definition of derivative? Yes, we're going to have to do that because we're going to have to prove ourselves. But before I go there, what if I tell you you already know this derivative? In words, what is derivative?
Slope of the tangent.
Slope of the tangent line. What is y equals 4x? It's just a straight line, yes? What is the slope at every point on this straight line? 4. So guess what the derivative of 4x is going to be? 4. Now, I'm not going to let you off quite that easy in that we're going to work through the process.
Can I just draw a graph?
I'm going to work through the process here. So the fact that my slope equals 4 means that my derivative is 4. And again, part of this, do you see what I'm doing here? I'm trying to draw you to connections. You've got to start thinking slope of tangent line, derivative, slope, derivative, back and forth. But as I said, not letting you off the hook quite that easy. We're going to prove this using definition of derivative. So, derivative of y with respect to x. The limit as what? Delta x approaches 0. Now it's f of x plus delta x. So take your function and every place you see n, x, replace it with x plus delta x. So what does that look like in this problem? If it was 4 times x, it's now going to be 4 times x plus delta x. Minus f of x. What is f of x? Just the regular 4x all over delta x. The math on this one is much easier than the math on the last one, isn't it? I'm going to keep rewriting the word limit as delta x approaches 0. Instead of foiling this time, you only have to distribute. So 4x plus 4 delta x minus 4x all over delta x. The 4x's will cancel. So officially I have the limit as delta x approaches 0 of 4 delta x over delta x. But what do you know then? The delta x's will cancel. So now I have the limit as delta x approaches 0 of 4. What happens when you put in 0 for delta x? There is no delta x, so there's no place to put 0. So the limit as anything happens here, your answer is 4. So even though you guys didn't really want to work that one out with me because you didn't want to use the definition of derivative, the definition of derivative can be very easy, or relatively easy, with an easy equation. The harder the equation, the harder the definition of derivative. Okay, example 4. Use the definition of derivative to show that the derivative of the constant function, f of x equals c, is 0.
It's cold in here.
It is?
I'm cold.
I thought that was your answer.
Yes, that's the answer.
It's cold in here is the answer to this problem. Well, that is a very interesting answer.
I wonder if they take that on the AP test.
It's cold.
They'll take whatever you give them on the AP test. Just don't expect points for it if you're going to do that then.
You're right.
Okay.
It's gonna look like an English essay.
Or maybe the 6th of Saturday, right in the Spanish.
Read it 500 times.
Okay. F prime of x. Definition of derivative. So, the limit as delta x approaches 0 of f of x plus delta x. So every place you see an x, you replace it with x plus delta x. What is my function? My function is c. Do I even have an x in here? No, so there's no place to replace it with x plus delta x, so that's just c. Minus f of x. What's f of x? C. All over delta x. And what is c minus c?
0.
So we have the limit as delta x approaches 0 of 0 over delta x. But 0 over anything is 0. So it's the limit as delta x approaches 0 of 0. Well, when you put in 0 for delta x, except there are no delta x's, you just are going to get 0. So we use the definition of the derivative to show that the derivative of the constant function is 0. When we say of the constant function, that's like saying f of x equals 4, which is like y equals 4. What does the line y equals 4 looks like? Y equals 4 is a horizontal line, and what's the slope of a horizontal line? 0.
We'll only have 2 problems with these anyway.
I'm chilly. Do you know what for lunches? Really?
Yeah.
I feel
I would-
We have the same things the other
It is chicken nuggets. You almost always have the same thing as the elementary. But it is chicken nuggets today because that's what Natalie read off the menu for me this morning. So,
chicken nuggets.
and Mallory, I was going to say I'll turn the heat up for you, but my thermostat's already at, I can't go anymore. So,
It's okay.
okay, guys, let y equal 1 over x. Find dy dx. We ready?
Yep. Let's get this bread.
Okay, so if we're finding dy dx, that means we're being asked to find definition of the derivative. Definition of the derivative starts off as, there we go, the limit is delta x approaches 0 of f of x plus delta x. Right. So if my function is 1 over x, that x now becomes x plus delta x. So it is 1 over x plus delta x minus f of x, which is just the 1 over x all over delta x. Okay, guys. If I plug in 0 for delta x right now, I get 0 over 0. It doesn't work. We have to do some serious algebra here. Yeah, essentially. Yes, that's exactly where we're headed here. Okay, so on top, I have a fraction minus a fraction, so I need a common denominator. What is the common denominator between x plus delta x and x? X times x plus delta x. Which means this first fraction, what's it going to have to multiply by? X. Which means the top is going to multiply by x. I'll write this out here on the next one. What's this second fraction going to have to multiply by? X plus delta x. And what you do to the denominator, you do to the numerator. Okay, first thing I'm going to write out is the limit as delta x approaches 0. Now, I'm going to go ahead and combine this in one fraction, if you don't mind, with a denominator of okay. So on top, we're going to have one fraction, common denominator, x times x plus delta x. What happens on the first fraction? We multiply top and bottom by x. On top, x times 1 is x. Minus. On the second fraction, we have 1 on top. We're multiplying by x plus delta x. So what are we going to have over here? Okay, now, which way do you want me to write this? We can write it as minus, in parentheses, x plus delta x. Or we could go ahead and distribute that minus and write it as minus x and minus delta x.
Let's do that.
Now, here's what I'll put up above. There. So you can either write it as x minus the x plus delta x, or if your brain will let you, just go ahead and distribute that subtraction. And this was supposed to all be over delta x, right? Okay, what cleans up? X minus x is going to cancel. So the limit as delta x approaches 0. The numerator of the numerator is going to be negative delta x over x times x plus delta x, and then all over delta x. Okay, we're past the worst of it, guys, I promise. I see fractions within fractions. How can I deal with fractions within fractions? Yeah, multiply by the reciprocal. And as I look at this, are we seeing the same fraction within a fraction? My top fraction is that whole thing, right? And then my bottom quote fraction is delta x. Okay, so let's write this out. Again, I'm going to start with the word limit as delta x approaches 0 of, I'm going to keep my top fraction, so negative delta x over x times x plus delta x. Normally it's divided by delta x, so instead of dividing by delta x, I can multiply by 1 over delta x, because we're multiplying by the reciprocal. And what is the lovely thing that's happening there? Delta x cancels. Last cleanup. The limit as delta x approaches 0. On top I have a negative and a 1, so negative 1 over x times x plus delta x. Okay, I've done all the simplifying I can. What do I do when I hit that point? Put in 0 for delta x. So now since I'm putting that 0 in, I'm taking the limit, so I don't need to write limit. And what does this become? Negative 1 over x squared. So the derivative of 1 over x is negative 1 over x squared. That's the ugly type definition of derivatives. Okay, I mean, just, that's when they get ugly, that's what they look like. So, work on those, because those will be part of life. Okay. I'm ready for example 6 when you are.
Oh, let's get this bread.
We're on the downhill slide, big time. Find the slope of the tangent line that can be drawn to the graph of f of x equals 1 over x at x equals 2. It's easy. It may look like another language right now, but it's easy. Yep. Now, he says, would it just be negative 1/4? And I said, yep. He still didn't give me any slope of the tangent line. What are we being asked to find? The derivative. And like earlier, it just so happens to be the same function we just did definition of derivative for. So this problem says f of x equals 1 over x. According to our previous problem, what is f prime of x then? And that's negative 1 over x squared. We were asked to find this at what point? At x equals 2. F prime of 2. Negative 1 over 2 squared, which I agree, takes us back to Logan's negative 1/4. Okay. You guys have your calculators with you today, right?
Yeah.
Okay. Example 7. Use a graphing calculator to approximate the slope of the graph of f of x equals 1 over x at the point 4 over 1, or 4 comma 1/4. What word did you see in there? Slope. What are we thinking then? Derivative. It said use a graphing calculator to approximate the slope of the graph of f of x equals 1 over x at the point 4 comma 1/4. Which the important part of that ordered pair, what is the x value? The x value is 4, and that's what we need to know. Okay, guys, how's the calculator help me out here? Okay, if you would please, math menu. Number 8 says what? Inderivative. Guess what your calculator will do? It will find the derivative if you have an x value to plug in. It's not going to find you the equation. Math menu. The button under alpha is math. So hit math. And then number 8 is inderiv. So arrow down to 8 or hit 8 and look what it brings up.
Wow. It's like a life hack.
Okay, now, right here, d over d blank. That is always your variable. So it will just be dx. In your parentheses is your function. What is the function we were given? 1 over x. And then it says x equals blank. At what x value are we doing this? 4. For this problem, it will not matter if you're in radians or degrees. Did we all get the same answer?
Yep.
Okay. Now, I'm going to write down some information in case you forget. If you're looking at your notes later. So, first of all, it was math menu, option 8. It is also in one of your alpha shortcut menus up top. I forget which one, but you'll find it. So,
It's in alpha window and it's number 3.
okay, you'll always be given that setup. You had to fill in x to make it d over dx. 1 over x was our function, and x equals 4 was the value. And our calculator told us approximately negative 0.0625. Okay, you got it? When you're ready, I would say try example 8. It says use a graphing calculator to approximate the slope of the graph f of x equals sine x at the point pi 0. So it said slope, so again your brain is saying derivative. They gave you a function, and what value do you need to use? Pi. So, d dx of sine x at x equals pi. When you put in sine, it's sine x, of course, into those parentheses around the x. And my screen just went out, so you can't see if your answer matches mine yet or not. Does your answer match mine?
No. Mine's in degrees. Yours is in radians, so I think that's why it's different.
You,
Well, that's lit. Let me change it.
let's try this.
Mine was in radians from home.
Okay, so
Now it does.
this is where the
That's
physics calc
happening.
battle continues
Pi.
because it was a trig function, sine x. It's not even the fact that we use pi because pi is just a number, but sine x, you used a trig function.
But remember you said a degree value is sine x, so it'd be degrees or
I guess then you would be in degrees, but I don't know. And that's where they do, I mean, so often it's radians. Okay, so the calculator answer, the correct calculator answer, is negative 0.999998333. What is that approximately? -1. Yes, so do watch. The mode only matters if you're working with the trig functions and the radian values. Okay? So it's kind of ironic when Logan happened to ask about the previous problem. The previous problem, it didn't matter. I did answer at that time, not on this problem. I guess I could have gone into more detail there, but
That is beautiful.
okay, guys. Practice with those derivatives.